Hello students, a very warm welcome to BYJU'S Classes. This is Nidhi and today we are going to discuss 26th February second shift mathematics paper which was held this year for JEE Mains conducted by NTA. Well, this question is from Matrices. They have given us the system of equations and they are saying that if A, B and C are real constants, then the system of equations will it have a unique solution when 5a is equal to 2b plus c, infinite number of solutions when 5a is equal to 2b plus c, and furthermore, two more options are given. That means I have to find the conditions for unique solution or no solution or infinite solution. Clear? Now, this again can be done in many number of ways. The first method which comes to our mind is by using determinants because that is already known to us. What do? We find four determinants. We find delta, then we find delta x, delta y and delta z. If delta becomes non-zero, that means I'm going to get what? I'm going to get a unique solution directly. If that is not the case and if I have all the four with me equal to 0, I'll get infinite solution. Similarly, I can also apply condition for no solution. But before doing that, I have to definitely get all these four determinants, right? So this might seem a lengthy question, right? I have to find delta, then delta x, delta y, delta z. If we don't want to use this, then what? Well, I have a shorter approach for you. Yes, we can do this question using rank of augmented matrix. You heard me correct. We can use this we can solve this question using matrix method and that too by using rank of augmented matrix. So first of all, what is augmented matrix? Well, if suppose I write this equation as Ax is equal to B, you already know what is A. A is the coefficients of x, y and z present in the equation. So my A will be 1, 2, minus 3, 2, 6, minus 11, 1, minus 2 and 7. Similarly, my x is nothing but the column matrix involving variables x, y and z, and B again is the column matrix involving constants A, B and C. So now I form an augmented matrix. Augmented matrix is nothing but when I write A and B together in a matrix form. So my augmented matrix comes out as 1, 2, minus 3, 2, 6, minus 11, 1, minus 2, 7 and then it's A, B and C. This is my augmented matrix. And now what do? Well, we try to subtract rows over here to create more and more zeros. And that is going to give me the rank or let's say the solution where I can have either a unique or infinite or no solution. So I'll explain it to you how to solve by this method. And guys, you are actually going to love this method. Trust me. So we have this augmented matrix with us, right? I've already rearranged the equation such that I get my A and B arranged like this. Clear? Okay, perfect. Now what? Well, now what am I going to do is I'm going to subtract my rows. So I'm going to apply row transformations as simple as you have learned in determinants as well as while finding the inverse of matrix. We are applying row transformations. R2 I'm changing as R2 minus R1 and R3 I'm changing as R3 minus 2R1. Clear? So when I apply it together, my R1 basically will remain unchanged. My R2 is going to become, when I subtract R2 and R1, it will be 0, minus 4, 10, C minus A. And when I write R3 minus 2R1, this 2 over here, the first element is going to become 0. While the second one will be 6 minus 4, that is 2, minus 11 plus 6, the third element will become minus 5. And it's going to become B minus 2A. Now what? Well, now again, when we look very carefully in this, my R2 has actually elements like minus 4 and 10, whose half value with a negative sign will become 2 and minus 5. What I'm trying to say is that I'm changing my R3 now again as R3 plus are 2 by 2. Because when I apply that transformation, I'm going to get another transformed matrix, or let's say the system of equations as 1, 2, minus 3a, 0, minus 4, 10, c minus a, and this is going to become 0. Then I have 2, which is going to become 2 plus minus 4 by 2. What is this value, guys? Quickly, 0. We have to create more and more zeros. Similarly, the next element will be minus 5 plus 10 by 2, again a 0. So that means I have created zeros over here. And now I'm left with the B column, or let's say the last part, which is going to become B minus 2a plus c by 2 minus a by 2, which can be written as B minus 5a by 2 plus c by 2. So this is now my transformed augmented matrix AB. Is it clear, guys? Now what? Now how are we going to apply the condition? Well, now if suppose you look at the last row which is written, it is converted into system of equations somewhat like this. Pay attention. I'm getting all the coefficients in my A as 0. So it's going to become 0 into x plus 0 into y plus 0 into z is equal to 2b minus 5a plus c by 2. I have taken the LCM. Now, guys, listen very carefully. I hope till now you have understood what we have done. We have taken the augmented matrix and we tried to create more and more zeros until we reached the last one where A last row is 0. I have a B column which is left in the last. And now I'm writing the last row in form of an equation. Clear? So, if I say that 2b minus 5a plus c is non-zero. Suppose it happens that for some values of a, b and c, my right hand part is non-zero. So can I get some values of x, y and z? No, you are right. We cannot get, because a 0 value cannot be equal to a non-zero value, right? So if it is non-zero, I can from here directly say that it is going to give me no solution. But if suppose my 2b minus 5a plus c becomes 0, or I can say that 5a comes out as equal to 2b plus c, what will I have? I'll have 0 is equal to 0, and I will be left now with only 2 equations. And how many variables do I have now? 3, correct. So my rank of A and rank of AB will be equal to 2, which is less than the number of variables, which is 3. And when this happens, when the last row becomes 0 entirely, we are left only with 2 equations in x, y, and z, and we have to find 3 variables. We say that this is the condition for infinite solutions. So here, this is the method, and I hope you have understood. Actually, it's simple as compared to finding all the 4 determinants, isn't it? So this is a new method. If you know it very well, if you do not know it, now try to also use this method sometimes in the questions you solve. So I have 2b plus c is equal to 5a, which is going to give me infinite solution. Understood? Perfect. Now, if we look at the options, we can say that B is going to be the right one. Well, next question is from probability. Again, a very easy question. Let's quickly read what the question is saying. A 7-digit number is formed using the digits 3 is occurring 2 times, 4 is occurring 3 times, 5 is occurring 2 times. The probability that number so formed is divisible by 2, that means it is an even number, right? So, if my number is divisible by 2 or it's an even number, the unit place should have even numbers 2, 4, 6, 8 and 0. But here they have made the calculation so simple. There is only one even number present, which is 4. That means the last position has to be occupied by 4. Clear? Okay, so now how are we going to find the probability? We have already seen the unit digit should be even. That means if I want to find my total cases, first of all, I'm trying to find what are the total cases. So my total cases will be equal to arrangement of these 7 numbers. How do we arrange these 7 numbers? When 2 are alike of one kind, 2 are alike of another kind, and 3 are alike of the third kind, it's nothing but 7 factorial divided by 2 factorial, 2 factorial, 3 factorial. Similarly, if I have to find the favorable one, why are we finding the favorable and total? To find probability, obviously. So now I have to find the favorable one, and we have just seen that the last place has to be occupied by even number, which is 4. So that leaves me with 2, 3, 2, 4 and 2, 5 to be arranged in the 6 places left. That means it will be done in 6 factorial upon 2 factorial, 2 factorial, 2 factorial ways. Right? So I have my favorable cases, I have my total cases. Probability will be equal to favorable divided by total. So when you divide this, what do you get, guys? The final answer as? Well, it is going to become 6 factorial divided by 2 factorial, 2 factorial, 2 factorial, whole divided by 7 factorial divided by 2 factorial, 2 factorial, 3 factorial, which is actually coming out as 3 by 7. This will become the final answer or the probability. Easy question, isn't it? Perfect. And the right option will become C. Well, the next question is from vectors. They have said that if vector A1, which is xi cap minus j cap plus k cap, and A2 vector, which is I cap plus yj cap plus zk cap, are collinear, then a possible unit vector which is parallel to xi cap plus yj cap plus zk cap is. They have given us 4 options. Okay. So let's quickly move on to the solving part. What they have mentioned is that 2 vectors are collinear. So first of all, I'll apply the condition for any 2 vectors to be collinear. What is that? One vector is equal to a constant times another vector. They will be either in same direction or in opposite direction, and their magnitude will differ. So I can quickly say that my A1 vector, let's say, is equal to lambda times of A2 vector. And if that is the condition, I can substitute my A1 vector and A2 vector and get a condition between x, y, and z by comparing the coefficients of I cap, j cap, and k cap. What am I saying is that if I substitute my A1 vector, it's xi cap minus j cap plus k cap is equal to lambda times of I cap plus yj cap plus zk cap. We can directly equate the coefficients of I cap, j cap, and k cap. Right? So when we do that, I'm going to get x is equal to lambda. Similarly, y will be equal to minus 1 by lambda and z will be equal to 1 by lambda. These are the values. And then what have they said? And then what have they said? That they want a possible unit vector parallel to xi cap plus yj cap plus zk cap. So on substituting the values of x, y, and z, I can get the vector as lambda I cap minus 1 by lambda j cap plus 1 by lambda k cap. And if I have to write a unit vector, I'll just put a plus minus over here divided by its magnitude, which will be lambda square plus 2 by lambda square. So what all possible values of lambda can I have to get the parallel vector? Well, I can put my lambda, let's say, as 1. So when I put my lambda as 1, I'm going to get the vector as I cap minus j cap plus k cap divided by root 3, or the entire negative of that is minus I cap plus j cap minus k cap divided by root 3. I can also put some another values, but looking at the options, they have either 1 by root 2 or 1 by root 3 with them. So definitely this vector I cap minus j cap plus k cap divided by root 3 is going to give me a possible parallel unit vector. And when I look at the options, I know the answer has to be C. Is this clear? Have you understood, guys? Perfect. A simple question, isn't it? Okay. So now The right option with us is C. Well, the next question is from definite integration. The question is saying that for x greater than 0, they have given fx as integral of 1 to x ln t divided by 1 plus t dt. Then what is the value of f of e plus f of 1 by e? Okay, so we have to find this value. How are we going to solve this question? Let's quickly substitute my value of f of e first. What is f of e? Well, you know it very well that in place of x here and over here, I have to put e. So I'm going to get my f of e as 1 to e ln t divided by 1 plus t dt. Similarly, my f of 1 by e value, I have to put in place of this x and this x again 1 by e. So when I do that, it's 1 to 1 by e ln t divided by 1 plus t dt. And now I have to find its summation. So what first thing comes to my mind is, can I actually solve my fx only? No, we cannot solve that, right? Ln t upon 1 plus t, we cannot integrate it directly. So what should I do? Well, I'll just write f of e plus f of 1 by e first. So when I write, it's going to become 1 to e ln t divided by 1 plus t dt plus 1 to 1 by e ln t divided by 1 plus t dt. Now, guys, these kind of questions are really very common. How can I solve these integrals, which are actually written as sum over here, or let's say subtraction? What is the first thing on which we should focus? Well, the first thing is, for any two integrals to be added or subtracted, or let's say combined, I have to concentrate upon making the limits for both the integrals as same. That means in the first integral, it's from 1 to e, while in the second integral, it's from 1 to 1 by e. Is these two limits same? Well, no. So my target first of all comes on to make the limit same. Rest of the terms definitely will get adjusted accordingly. So I'm not touching my first integral, let's say I1. I'm just touching, or let's say making changes in my second integral, which is I2. So quickly, when I solve for I2, I can say that I2 is 1 to 1 by e ln t divided by 1 plus t dt. What am I doing in I2? I have to make 1 by e 2e. That means I'll use a substitution. I'll put t as 1 by t over here. I'm replacing t as 1 by t. So when I do that, it's going to give me the limit as 1 to e, because 1 by e reciprocal is e, while 1 reciprocal is 1. But my ln of t is going to become ln of 1 by t, which is nothing but minus of ln t, right? Divided by, I'll have 1 plus 1 by t, and the derivative, well, the derivative will become minus 1 by t square dt. Clear? Perfect. So let's quickly take the LCM, and the minus sign actually is going to get cancelled out. So it's going to become ln t divided by 1 plus t, and I'll have one more term, which is 1 by t dt. So I have converted I2 such that my limit is now matching with I1, right? Now what? Well, now we'll find the summation I1 plus I2. So now if I substitute, it's going to become 1 to e ln t divided by 1 plus t dt. This was I1, plus I have 1 to e ln t upon 1 plus t into 1 by t dt. And guys, this you already know. If the limits are same, we can combine the inner terms, right? So it's going to become plus times of ln t divided by 1 plus t into 1 by t dt. And now you can quickly see, you can actually see that ln t by 1 plus t is coming out common. So on taking that common, it's going to become 1 to e ln t divided by 1 plus t. I'll have 1 plus 1 by t. And here in this bracket, if I take LCM, it's going to become 1 plus t by t dt, right? And this 1 plus t is getting cancelled out. Understood? So finally what we are left with? Well, we are left with ln t divided by t dt, which is now very easy to integrate, because you know that if I take ln t, let's say as z, my derivative 1 by t dt will definitely become dz, right? So when I do that, I can directly integrate it and substitute the value. It's going to become z dz, integration will become z square by 2. And what about the limit? Well, if my t is 1, my ln 1 will become 0. While if my t is e, my ln e will become 1. The value finally comes out as 1 by 2. This will be the final answer. Again, not at all a much difficult question, I would say. It's not that much difficult, but yeah, you have to remember, whenever we have to combine one, let's say two or more integrals, what do we focus upon? Making the limits same always. Most of the time, the inner part actually simplifies. And when we try to add or subtract whatever is given to us in the question, we get a much more simplified form like we have obtained here, which is just ln t by t. Therefore, integrating it directly, we've got the final answer as 1 by 2. Understood? So yeah, it required a bit of thinking. I'm not denying that. If you cannot do this question in your first attempt, leave it, go to the next question and come back when you have attempted all the easy questions which you found in the paper. This requires a bit of thinking, and therefore, if you are not very well versed with the approach, you have to think and give it a bit of time. But I hope after this discussion, now you'll remember this approach, isn't it? Whenever we combine integrals, what do you have to focus on? Limits. Correct. We have to try to bring both the integrals in the same limits so that we can apply something and combine the terms. Understood? Perfect. So the option correct will become A. Well, the next question is from continuity. The question is saying let f defined from real to real is defined as, there are three definitions for f. If x is less than minus 1, it's defined as 2 sine minus pi x by 2. If it's lying between minus 1 to 1, it's defined as modulus of ax square plus x plus b. While if x is greater than 1, it's sine of pi x. And it's given that the function is continuous, then the value of a plus b is. We have to just apply the concept of continuity. That means question should not be that much difficult, right? So quickly, we have to attempt this question. Let's see what do we get the answer as. So we have to find the value of a plus b is what they have asked in the question. Now, since my sine definitely is a continuous function, my modulus of a quadratic is a polynomial. Polynomial is continuous. When I take its mod, definitely the function will again be continuous. And then I have again a function of sine. So that means my f will be continuous except at points where the definition is changing, right? So that means I have to check continuity only at points that are minus 1 and 1. At rest of the points, the function definitely will be continuous. Clear? So if I have to check my function's continuity at x is equal to minus 1, what are the conditions I'm going to apply? That my f of minus 1 minus should be equal to f of minus 1 should be equal to f of minus 1 plus. You know the trick, limiting values we have to write. So when my x is less than minus 1, I'll just put my x as minus 1. So the value in this 2 sine of minus pi x by 2 is basically 2 sine of pi by 2 is equal to, when I put my x value as minus 1 or slightly greater than minus 1 in this quadratic, it's going to become mod of a minus 1 plus b. So that means I have my a plus b minus 1 whole modulus as 2. And when I remove modulus, what will I get? Plus minus sign on the right hand side, right? So it's going to become a plus b minus 1 is equal to either 2 or minus 2. So from here, actually, I'm getting two values of a plus b, which are 3 and minus 1. Okay. Now what? Which of these two should we take? Well, we don't have to worry. We have to check continuity at x is equal to 1 also, which is left, right? So again, applying the conditions, we know that f of 1 minus is same as f of 1 is same as f of 1 plus. When I apply the limiting values, so when I concentrate about my 1 minus, it will be from the quadratic. Definition will be a plus 1 plus b whole mod is equal to, when I talk about x as 1, so the value will be sine of pi. The limiting value, that is sine of pi, which is nothing but 0. That means my a plus b plus 1 has to be 0, which is going to give me the final value which was required is a plus b is equal to minus 1. And what one more thing you have to remember is that this value is common with the part with when we have checked continuity for x is equal to minus 1. That should happen, right? We should get the common value in both the cases. Then only a plus b is equal to minus 1 will be acceptable, which is indeed the case here. A plus b is equal to minus 1 is coming from for both the cases. That means my final answer of a plus b will be equal to, or the final value of a plus b will be equal to minus 1. Understood? Perfect. And the right option will become B.